All right, problem number 4. Another tricky problem. Chicken nuggets come in boxes of 6, 9, or 20. What is the largest number of nuggets that you cannot buy when combining various boxes? All right. Well, let's simplify this a little bit. Let's just look at 6 and 9, okay, for right now. Let's not worry about 20 right now. Let's just look at 6 and 9 and see what combinations of um, boxes we can get out of just boxes of 6 and 9, okay? And the reason I see, or the reason I chose 6 and 9 is because I see a common factor between the two. You know, they're both multiples of 3. And you can see that um, if we just start with 6, what can we get out of 6? Well, we can get 6, or we can get 12, or we can get 18, or we can get 24, 30, and so on, right? So essentially we can get all of the even multiples of 3, right? Because 6 is just 2 times 3. Okay, so if something is divisible by 6, it has to be even, and it has to be, digits have to add up to 3, right? So, but anyway, so all the multiples of 6 are just the even multiples of 3, okay? Now, I have a table I want to bring up here, and just mainly because I don't want to make you wait for me to list out all these numbers, but I wanted to be able to keep track of where we're at with when we're looking at these different combinations of chicken nuggets. So I'm just going to look at 6 right now, and I'm going to highlight the ones that I can get. Oops, I should probably just use the yellow highlighter. Okay, so we can get 6, we can get 12, we can get 18, we can get 24, 30, 36, 42, 48, okay? And so on. I mean, I can make this table longer, but hopefully we'll come to that biggest number that we cannot get before we get to 51. If not, we'll just add more numbers to the table. But so I'm highlighting the numbers that we can get, okay? So we know we can get the even multiples of 3, okay? And you notice I also arrange these numbers in columns, so, 3 columns going 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's a reason I did that as well, because it'll help you see where we're going. And I use 3 because it's a common factor between 6 and 9. But so anyway, so that's where we're at so far. Okay, so 6. Let's say multiples of 9. Now we could look at multiples of 9. But we get evens and odds. But we can also look at if we start with 9 and then we add a multiple of 6, okay? Because if we start with an odd number and we add an even multiple of 3, okay, so it's an odd multiple of 3 plus an even multiple of 3, it's going to give you an odd multiple of 3, right? Does that make sense? Hopefully I explained that well. Okay, so here we got all the even multiples of 3 up here. Even multiples of 3. And if we take all of any of those even multiples of 3 and add 9 to it, we will get odd multiples of 3, okay? So, actually, I'm going to write it like I just said. Plus an even multiple of 3 is equal to an odd multiple of 3, okay? So, because you know that if I take a multiple of 3 and I add a multiple of 3 to it, it's still going to be a multiple of 3, right? Because multiplication is just repeated adding okay? And so if I add, so like I said, if I take a multiple of 3 and add a multiple of 3, it's going to be a multiple of 3. And in this case, if I take an odd and add an even, it's an odd number, okay? So 9 plus an even multiple of 3 is going to give you an odd multiple of 3. Okay. All right, so let's highlight those numbers. Okay. Now, obviously, we can't get 3 because the smallest box is 6. So we can get 9, all right? And then if we add even multiples of 3 to 9, we'll get 15, 21, 27, 33, 39, 45, and 51. So basically all the multiples of 3 except for 3, right? All right, well, that narrows, that you know, we're getting it narrowed down, right? So what else? Now, I think we've pretty much exhausted 6 and 9 with what we can do with 6 and 9. So I think we've got to move to 20 now, okay? So, well, with 20, we know that obviously we can get 20, and we could get 40, okay? Because we'd get 2 boxes of 20, and we'd have 40. So we know we can get that. And we also know that we could take 20 plus any of these that we already got, right? 6, 9, 12, 15, all these multiples of 3 except for 3. We could add that to 20, and we could get 26, 29, 32, 35, 38, 41, 44, 47, and 50. Okay? So when we add, you know, something from this third column to 20, we will, you know, just get, we'll get 20 plus 6, 9, 12, 15, 18, right? And so on. So, and once, you know, basically we can get all of them. I mean, I didn't write all these numbers out, but this just goes on forever, right? Okay. All right. So let's do the same thing for 40. Now, if I take 40 and I add a multiple of 3 other than 3, then I will get 46, 49, and so on, right? 52, and I can just keep going, all right? So I've basically taken care of all of these columns, all right? I mean, we can get every number in the third column except for 3. We can get the numbers in the second column starting with 20, but we can't get 23, and then we can get all the rest, okay? And we can get all the numbers in the first column starting with 40, but we can't get 43. So now you can see what the biggest number or the largest number of nuggets that we cannot buy is, right? It's got to be 43. Okay, I'm actually going to use the highlighter because I'm having fun with the highlighter. Oops. And so you can see we cannot get 43. Alright, and so the answer is 43 nuggets. Okay, so hopefully that made sense to you. It's just a matter of, you know, like we eliminated, or we can get everything in the third column except for 3, and then if we just take that column and add it to the biggest number we can get, or the smallest number we can get in that column, then we'll get everything, you know, 20 plus any of these multiples of 3 is going to be, we'll be able to get all these numbers, and 40 plus a multiple of 3, other than 3, will give us all the numbers in this first column. Okay, so anyway, you got it now, right? There you go.